Hello everyone, this is the second part of engine fundamental presentation material and which focus on introduction to vehicle. The content of this presentation are introduction to automotive systems and introduction to hybrid vehicle. The learning objective. After this presentation, the students are able to explain an automotive system, demonstrate an automotive electrical system, describe an automotive chassis, elaborate an automotive transmission, discuss an automotive frame and the body, explain hybrid vehicle. Automotive system. Automotive systems are systems installed on cars to enable the car to work properly. To mention them, computer system, fuel system, electrical system, and under electrical system we have ignition system, starting system, charging system, lighting system. The other automotive system is cooling system, lubrication system, exhaust and emission control system, drivetrain system, suspension system, a steering system, brake system, accessory and safety system, frame, body and chassis. The computer system. Nowadays, modern vehicles use a lot of computers to control the vehicle. So computers use electronic and electrical devices to monitor and control various systems in the vehicle, including fuel, ignition, drivetrain, safety, and security system. From this picture, we can simply understand the different systems of the vehicle which use computer. So the computer system is used to monitor fuel, ignition, drivetrain, safety, and security system. The use of computer systems has improved vehicle efficiency and dependability. Additionally, most of these systems have self-diagnostic capabilities. Major part of an automotive computer system. Sensors. Sensors are input devices that can produce or modify electrical signals which with a change in a condition such as motion, temperature, pressure, etc. The sensors are the eyes, ear, and nose of the computer system. The other component of the computer system is the control module. The computer or electronic circuits that use signals from input device, sensors, to control various output devices. The control module is the brain of the computer system. This picture illustrates a lot of different sensors. Camshaft sensor, airflow sensor, coolant sensor, engine NOx sensor, crankshaft sensor, temperature sensor, map sensor, NOx sensor, oxygen sensor, speed sensor, voltage sensor, and throttle position sensor. These are some of the examples of the different type of sensors used in automotive technology. The other part of the computer system is the actuators. Actuators are simply output devices, such as a small electric motor that can move parts when energized by the control module. The actuators serve as the handles and arms of the computer system. So the vehicle, especially the computerized vehicle, use various type of actuators. So these all are actuators. All are actuators. So the actuators can be motors, or they can be solenoids. The fuel system. It provides the correct mixture of air and fuel for efficient combustion. The fuel system alters air-fuel ratio, which means percentage of air and fuel which change in operating condition. Engine speed, engine temperature, load, and other variables. Let's see this picture. From this picture we can see the different components of the fuel system. The first part of the fuel system is fuel pump, and which can be located inside or outside. The fuel tank, the fuel line, the pressure regulator, and here we have injector, and also regulator and high pressure pump, and fuel filter are also incorporated here. Type of automotive fuel system. There are three types of automotive fuel system: the gasoline injection fuel system, the diesel injection fuel system, and the carburetor system. The gasoline injection system. Modern gasoline injection system use a control module, sensor, and electrically operated fuel injector or fuel valve to meter fuel into the engine. This is the most common type of fuel system on gasoline or spark ignition engine. The GDI or the gasoline direct injection system layout is indicated in this picture. So from this picture we can see the different components of the gasoline injection system. So the injection system starts from the fuel tank, and here we have ECU, and here this is the engine and the injector. The second type of fuel injection system is the diesel injection system, primarily a mechanical system that forces diesel fuel but not gasoline directly into the combustion chamber. Unlike the gasoline engine, the diesel engine doesn't use spark plug to ignite the air-fuel mixture. Instead, it uses the extremely high pressure produced during the compression stroke to heat the air in the combustion chamber. The air is squeezed until it is hot enough to ignite the fuel. The electronic diesel fuel injection system is shown here. Carburetor fuel system. The carburetor fuel system uses engine vacuum or suction to draw fuel into the engine. The amount of airflow through the carburetor determines the amount of fuel used. This automatically maintains the correct air-fuel ratio. The picture shows the carburetor fuel system. The carburetor fuel system, the main components are the fuel tank, the fuel line, the charcoal canister, the fuel filter, the fuel pump, and also the carburetor. Either a mechanical or an electric fuel pump draws fuel out of the tank and deliver it to the carburetor. The engine's intake stroke forms a vacuum inside the intake manifold and carburetor. This causes the gasoline to be drawn from the carburetor and into the air entering the engine. So the carburetor system can be simply understood from this picture. So the first picture here shows the flow system. So in the flow system, the amount of fuel captured inside of the carburetor is regulated. So this is the inlet of the fuel to the reservoir in the carburetor, and this inlet can be opened and closed by the needle valve. In the second case, when the system is activated, then the fuel is drawn from the carburetor. So this is the uh, idle system. So in the idle system, the fuel is injected through the idle line, and here there is idle adjusting screw, and the throttle valve is closed. In this case, the throttle valve is open, and at this time the main jet supply the required amount of fuel. So the fuel and air are mixed in this chamber. And in the acceleration case, when the driver depresses the pedal more, and at that time acceleration pump is activated and the fuel or additional fuel is injected to the chamber through this port. And the other is the choke. In the choke system, when the choke valve is at closed position, so at this time during cold start, the choke, the fuel is injected through this port. Electrical system. The vehicle's electrical system consists of several subsystems or smaller circuits: ignition system, a starting system, charging system, and lighting system. Each subsystem is designed to perform a specific function, such as fire the spark plug to ignite the engine fuel mixture, rotate the crankshaft to start the engine, and illuminate the highway for safe night driving, etc. Ignition system. Ignition system is needed on gasoline engine to ignite the air fuel mixture. It produces an extremely high voltage surge which operates the spark plug. A very hot electrical jump across the tip of each spark plug at the correct time. This causes the air fuel mixture to burn, expand, and produce power. This type of ignition system is the conventional one, and it is mechanical. So the primary circuit is open and closed by using the contact breaker point, and we call it just mechanical. The other version of the ignition system is electronic. We call it electronic because the mechanical components are removed and replaced by transistors. So in these two cases, the ignition system use transistor or computer to control the primary circuit. Starting system. The starting system has a powerful electric starting motor that rotates the engine crankshaft until the engine fire and run on its own power. Let's see the components of the starting system: the battery, starter motor, pinion ring, ring gear, and ignition gear. And here the whole component or part of the starting motor are clearly visible. And this is the circuit, how the starting system works. The charging system. Charging system is needed to replace electrical energy drawn from the battery during the starting system operation. To recharge the battery, the charging system forces electric current back into the battery. Let's see the component of the charging system. The battery, generator or alternator, power control unit, charge indicator lamp, interior fuse panel, and the charging system fuse box. Or this is also a power distribution center here. So this is the simple circuit for the charging system. Lighting system. The lighting system consists of the components that operate a vehicle's interior and exterior light, such as fuse, wire, a switch, a relay, etc. The exact circuit and part configuration will vary from one model to another. Exterior light typically include headlight, turn signal, brake light, parking light, backup light, and also side marker lights. The interior light includes the dome light, trunk light, instrument panel light, and other courtesy lights. Exterior lights are illustrated here. So, in the front, in the back. And these are the overall view of the light mounted on vehicle. And when we say interior, we can simply understand the lights which are mounted inside of the vehicle to illuminate the interior part of the vehicle. So it includes all lights which are mounted inside of the vehicle, and the exterior light mean all light components which are mounted outside of the vehicle. Cooling and lubrication system. The cooling and lubrication system are designed to prevent engine damage and wear. They are important systems that prevent the engine from self-destructing. The cooling system maintains a constant engine operating temperature. It removes excess combustion heat to prevent engine damage and also speeds engine warm-up. So the cooling system can be seen in this picture. So we can simply understand the different component of the cooling system. Here we have a reservoir, and this is the radiator and the fan, and also the line, the hose, the upper and the lower hose. You can see, and here how the coolant circulates inside of the vehicle. So the hot coolant leaves the engine via this line or the upper hose, and it passes through the radiator, and during passing through the radiator the heat is released. Then the cold coolant enter again into the engine. So by doing this, the temperature of the engine can be maintained. Lubrication system reduce friction and wear between internal engine parts by circulating filter engine oil to high friction point in the engine. The lubrication system also helps cool the engine by carrying heat away from internal engine parts. So in the lubrication system we have oil pan, and this oil pan store the engine oil, and this engine oil is pumped by using the oil pan, and the pumped oil enter into the filter or oil filter, and the filtered oil leaves the oil filter and enter and distributed to different part of the engine. And finally, the oil returns back to the sump. Exhaust and emission control system. The exhaust system quiets the noise produced during engine operation and routes engine exhaust gas to the rear of vehicle body. Let's see the components of the exhaust system. This is the engine. So the engine releases the exhaust matter through the exhaust manifold. So the exhaust manifold collects those exhaust gas and it passes them to the mid pipe, then the catalytic converter, then the exhaust pipe P, then finally muffler, and at the end the exhaust pipe tip. Drivetrain system. The drivetrain transfers turning force from the engine crankshaft to the drive wheel. Drivetrain configuration varies depending on vehicle design. So we can see here the different layouts. Here, the front engine, front drive vehicle layout. And here we have a different layout, which is a front engine and four-wheel drive. The four-wheel drive case, we need a transfer case to distribute the power to the front wheel and also to the rear wheel. So this is the simple picture to illustrate the front engine rear wheel drive. Suspension, steering and brake system. Introduction to under chassis. The suspension, steering and brake system are the movable part of the chassis. They bolt or anchor to the frame and provide important function that will be explained in the following section. Suspension system. The suspension system allows the vehicle's wheels and tire to move up and down with little effect on body movement. This makes the vehicle's ride smooth and safe. Suspension system also prevents excessive body lean when turning corners quickly. Independent suspension. McPherson thrust suspension, the double wishbone suspension, the multi-link suspension, trailing arm suspension, non-independent suspension, solid axle coil suspension, solid leaf spring suspension, and air suspension. Steering system. The steering system allows the driver to control vehicle direction by turning the wheels right or left. It uses a series of gear, a swivel joint, and rods to do this. We can see the picture here. From this picture, we can simply understand the two types of steering. The first one is rack and pinion type of steering. So in the rack and the pinion type of steering, we have a rack and also pinion gear. The other is the pitman arm type of steering. So in the pitman arm type of steering, we have a steering gear which can change the steering wheel actuation force to apply on the steering arm. So we can see here the different parts of the steering wheel. Brake system. The brake system produces friction to slow or stop the vehicle. When the driver presses the brake pedal, fluid pressure actuates a brake mechanism at each wheel. This mechanism forces friction material, brake pad or shoe against metal disc or drum to slow with rotation. So the brake on the vehicle is illustrated here, and you have the quarter brake picture is illustrated here. So the pedal, the brake pedal, is applied by the driver. The brake fluid, and it is pushed by the applied force. And here there is a brake pad, and this pad is pushed by the applied pressure of the driver. And we have a rotating disc, and this rotating disc is slowed by applied force due to the brake application. Drivetrain systems. Introduction to transmission. The drivetrain transfers turning force from the engine crankshaft to the drive wheel. Drivetrain configuration vary depending on vehicle design. The drivetrain parts commonly found on a front-engine rear-wheel drive vehicles include the clutch, transmission, drive shaft, and rear axle assembly. The drivetrain parts used on most front-engine front vehicle drive include clutch, transaxle, and drive axle. The picture illustrates the drivetrain of the vehicle. So you can see the first picture. In this picture, the engine is located in the front, and the power is distributed to the rear wheel by using the power transmitting device. And in the picture B, we can see the engine located at the front, and the power is transmitted to the front wheel by using transaxle. So here, transmission and differentials are combined together to make transaxle. Accessory and safety system. Common accessory systems include air conditioner, sound system, power seat, power window, and rear window defogger. Common safety systems include seat belt, airbag, and security system. In this picture, you can see the different components of the air conditioning system. So the air conditioning systems are the comfort system mounted on the vehicle to provide comfort working environment to the driver. Frame, body, and the chassis. The body and the frame are the two largest sections of a motor vehicle. The frame is the strong metal structure that provides a mounting place for the other parts of the vehicle. The frame holds the engine, transmission, suspension, and other assemblies in position. Let's see the two pictures. This is the complete chassis. So the frame with different parts of the vehicle. And this one is a unibody type of construction. So the body is constructed together with the frame. So you can remove or separate the body from the frame because the body and the frame are developed separately. The body. The body is a steel, aluminum, fiberglass, plastic, or composite skin forming the outside of the vehicle. The body is painted to give the vehicle an attractive appearance. Automobiles are available in several body types, including the sedan, hardtop, convertible, hatchback, and station wagon. In addition, the minivan, the sport utility vehicle, and pickup truck have become increasingly popular. Let's see this different picture to understand more about the body of the car. This design is a sedan type of body design, and we have a convertible, so this part can be converted, and we have also hatchback type of body. So this or the rear part of the vehicle or the tailgate can be open, and we have also station wagon. In this station wagon there is additional space at the rear of the vehicle to have more passenger, and we have also minivan again. The side of the minivan is higher, and also the shape is different from the sedan and the hatchback. And the last version of the car is the sport utility vehicle, and this sport utility vehicle is size is somewhat higher than the other passenger car. So the wheel size is larger, and the vehicle raises high height from the ground. And there are also trucks. Chassis. The term chassis is often used when referring to a vehicle's frame and everything mounted to it, except the body, tire, wheels, engine, transmission, drive axle, assembly, and the frame. Hybrid vehicle. Most auto manufacturers now build and sell hybrid vehicles. A hybrid vehicle uses two methods of propulsion: an internal combustion engine and a large electric motor generator. To help improve vehicle performance, acceleration, increase fuel economy, that means gas mileage, and reduce emission or air pollution. So the hybrid vehicle use two type of source. The first type is the internal combustion engine, and the second part is the battery or electric, and it can be a fuel cell. And in the hybrid vehicle there are different components, and we can see them. The plug-in hybrid vehicle components. So this picture shows the component of the plug-in hybrid vehicle. So some hybrid vehicles don't have external charging mechanism. So the battery can be charged by the generator of the vehicle itself. But if the vehicle is externally charged, then we can call it plug-in hybrid. Let us about the fundamental part of a hybrid vehicle. The first part is the motor generator. The motor generator device that can propel the vehicle like a motor or produce electrical energy like an alternator. The high voltage cable. Large diameter insulated conductor that carry voltage between the motor generator, hybrid control module and the battery pack. So the HEV cable color standard is orange. So all orange cables on the vehicles are HEV in nature. So the technician should be aware of the HEV cables and the danger of the high voltage current. When we came to the cable is made up of different parts. So the first part is a shield, and this is the upper part. Then next to the shield, we have the braid and the tip. And the third part is the insulation. And the fourth part is the conductor. So to be safe, the conductor is covered by three different layers. The other component of the hybrid vehicle is the control module. So the hybrid vehicle is the control module, and this control module is a high power electronic circuit that manage the flow of electrical energy through a vehicle's electrical mechanical drivetrain. The other component of the hybrid vehicle is the hybrid battery pack. The hybrid battery pack is shown in this picture, and it is a large set of battery cell that can store huge amount of electrical energy and output high current and voltage to help propel the vehicle. And also the internal combustion engine is part of the hybrid vehicle. Gasoline or diesel engine that propel the vehicle at cruising speed and drives the motor generator. Thank you for watching this presentation, and if you are interested, please share the material with your colleague. Thank you.